everyone, and welcome to our webinar on EV charging station installation training. I'm April Bolduke, President of S-Curve Strategies with over 10 years of experience with EV infrastructure projects. And I'm joined by Randy Shimka, our EV charging expert and electrical engineer. In this webinar, we're going to guide pre-apprentice technicians, facility managers, students through some great information about EV chargers and reliable installation techniques. Our objectives are to help you learn about and master installation techniques, understand the National Electrical Code compliance, and help get prepared for the Electric Vehicle Infrastructure Training Program certification, or wherever the next step is on your journey to become certified. We'll cover the site assessments, electrical setup, load management, and more. And this training session was made possible by the County of Los Angeles and the California Energy Commission. So join us for a follow-up session on service and maintenance, which is also posted on the County of LA website. In addition, the County of LA and the California Energy Commission made possible a 5-part series on best practices for EV installations, and that covers strategic site selection, business models and financing, regulation and implementation, permitting, site design, and operation. And these can also be found on the County of LA website and will be great additions to your training today. So let's dive into the world of EV charging infrastructure. It's great to be here. I'm April Bolduke, President of S-Curve Strategies, and over the last 15 years, I've done hundreds of EV charging site walks. I spent a decade at San Diego Gas and Electric, with most of that time on their EV charging infrastructure team. And since starting S-Curve Strategies, over 8 years ago, I've worked on transportation electrification projects across 13 states. I've been driving electric since 2011, and I'm excited to share the best practices that I've learned. And Randy, I'll turn it over to you.
All right. Hello, everybody. My name is Randy Shimka from S-Curve Strategies, where April and I have worked on various EV and charging-related projects for several years. I bring over 35 years of utility engineering experience to the table, including a decade focused on clean transportation vehicle and charging station projects. My educational background is in electrical engineering, and I also have a California professional engineer credential. As April knows, I'm very passionate about EVs, and I drive an EV daily, as well as we do lots of electric road trips in our cars, and we often take detours on our trips so we can look at new charging stations and see what's been installed since our last visit. The growing EV charging network makes every road trip fun, and we try to charge in new places all the time. So I'm thrilled to be here today to share my insights with you on EV charging station installations.
These 3 objectives will help set the foundation of our EV charger station installation discussion. We want to emphasize the importance of mastering EV charger installation techniques and compliance with standards like the National Electrical Code, Article 625 for safe and efficient setups. Reliable charger installations are critical for long-term performance and user satisfaction. So by focusing on consistent, accessible, and seamless charger experiences, we'll meet driver expectations effectively. These goals will help shape our discussion of best practices. So let's begin with an overview of our agenda. Here's the agenda for our EV charging station installation effort today. We'll start by exploring an introduction of EV chargers and discuss their network systems, followed by ADA compliance, requirements to ensure accessibility. And next, we'll cover the installation process, emphasizing safety practices, thorough site assessments to set up durable, robust, and compliant systems. We'll then address common mistakes to avoid costly errors, review real-world case study for some practical insights, and discuss certifications like the EV Infrastructure Training Program that helps validate expertise. Finally, we'll share valuable resources to support your projects. This agenda covers the main topics of a comprehensive guide to successful EV charger installations. And let's begin with an introduction to EVs. When it comes to EVs, there are 2 main types being sold today. Battery electric EVs are fully electric like the Tesla Model Y. They're powered solely by batteries and need to be charged for daily operation. And many BEVs have battery ranges that greatly exceed the average daily commute of most drivers, so they don't need to be charged as often. Plug-in hybrid electric vehicles combine electric and gas fuel, such as the Toyota Prius, and typically use smaller batteries and are supplemented by gasoline fuel. These vehicles can drive electric locally and then switch over to gasoline for longer drives. There is a growing demand for chargers due to increased EV sales. For example, in 2024, California had over 1.2 million EVs registered. That's out of 26.7 million vehicles total. In LA County, nearly 400,000 EVs were registered out of 6 million vehicles on the road. So that number of EVs is definitely growing. When it comes to designing effective EV charging stations, one of the first steps is to understand the requirements of the EV charging site, such as the quantity of chargers required and the power levels required. So let's talk about the EV charging network. The network connectivity can help to ensure efficient, reliable, and user-friendly EV charging infrastructure. So let's start by discussing the types of EV charger stations and the various connectors. Randy, can you walk us through those?
Sure. So there's three different types or levels of EV charging, and the main differences between them is mainly the speed of charging, which dictates the type of charging equipment required. Level 1 charging uses a standard 120 volt connection at 12 to 16 amps, which is ideal for home charging, but it is slower, delivering about 4 miles of range added per hour of charging. Level 2 charging uses a 208 or a 240 volt connection, and the current level can range from 16 to 80 amps, which is common in a lot of homes and workplaces, but will require a specialized level 2 charging station. Level 2 charging can add about 25 to 45 miles per hour, but this really depends on how fast the car will allow charging to take place. So direct current fast charging, or DC fast charging, can deliver from, say, 50 to 350 kilowatts of power. And of course, that depends on the charger and the car. And it can add between, say, 100 to 200 miles in 20 minutes of charging, which is great for a quick top off or on-the-road trips. AC charging, which is used in level 1 and level 2 scenarios, is slower but simpler hardware-wise, while DC charging requires more complex infrastructure and equipment, as well as associated hardware on the car side. The different types of charging will dictate what sort of electrical infrastructure and equipment is needed for the site. When it comes to charging connectors, they're the physical link between EV charging and the vehicles. The main type of connectors include the Society of Automotive Engineers, or SAE, J1772 connector, which is used for level 1 and level 2 charging, and the Combined Charging System, or CCS, for AC and DC fast charging, and the North American Charging Standard, known as NACS, developed by Tesla and is also used for both AC and DC charging. The NACS connector is quickly becoming the new standard for charging and has been adopted by the majority of car manufacturers. So that's the connector that we'll most likely see on cars and charging stations going into the future. Wireless charging, which is an up-and-coming technology, allows more flexible and convenient charging without cables. There's a transmitter installed on the floor and a compatible receiver that is installed on the bottom of the car. The transmitter and receiver have to be right on top of each other for charging to function properly. Any mismatch will result in low or no transfer of charging power. And there's typically a 5 to 7% loss of energy during a wireless charging session and a higher overall installation cost. Battery specifications directly influence EV charger power requirements. Depending on the vehicle, EV batteries can operate at different voltage levels, such as 400 volts or 800 volts DC, and that dictates the type and power level of charger that is needed. Mismatched chargers can lead to inefficient charging, longer charge times, or even potential damage to the battery. The good news is that most light-duty EVs that are sold today use standardized chargers and connectors, but there are some vehicles sold, such as golf carts or neighborhood electric vehicles, that use proprietary chargers that are sold by the manufacturers. Lithium-ion batteries currently lead the EV market with high energy density, long cycle life, and fast charging. However, they're more expensive and are sensitive to temperature extremes. Nickel metal hydride batteries were used in early hybrid vehicles, and they offer better energy density than NiCad batteries, but less than lithium ion. So they have good temperature tolerance and a lower risk of thermal runaway. Nickel cadmium batteries are older technology, and they're rarely used these days due to low energy density and the memory effect of only wanting to charge to the level that we store the batteries at. These are the cheapest batteries, but the toxic nature of cadmium limits its use these days. Communication systems make chargers smart and reliable. When it comes to the communication between the car and the charging hardware during a charging session, there are key standards that are used for secure and efficient communications. Authentication methods like the International Electrotechnical Commission's ISO 15118 standard enable automatic vehicle identification to the charging infrastructure, and this helps to initiate charging settings and makes the authentication, charging, and billing processes more transparent to the driver. RFID tags and mobile apps also allow user access to charging stations, and they ensure that only authorized users can charge at the site. The standardized Open Charge Point Protocol, or OCPP, facilitates the charger to back-end communication, which helps to enable remote monitoring and billing and makes chargers more interoperable. Charger to back-end systems communications using secure browser connections and virtual private networks help protect data and prevent cyber attacks. Regular firmware updates, which are usually issued by the manufacturer, are critical to address cyber threats and for maintaining system reliability. These communication security systems help to ensure secure charging sessions. Charging companies manage EV chargers and provide billing and monitoring functions. This is important to the site hosts because they can monitor this functionality in real time via a dashboard and see important information about each charging station and whether it's working properly. Some of the larger EV charging providers these days include Tesla, ChargePoint, EVgo, Electrify America, Blink, and PowerFlex, to name a few. Their networks handle payments using industry standard OCPP communications, which enables seamless charging sessions via billing, via apps, or cards. Some providers now offer automatic authentication upon plugging in so that charging can start automatically. As an installer, you'll be responsible for the charging station and infrastructure installation and may also be involved in the testing of the communications network, which can be via either cellular or Ethernet or Wi-Fi. One thing we want to mention, however, is that not all charging station installations require the additional expense of networking. Sometimes it just makes sense to have a row of non-networked charging stations behind a fence to charge fleet vehicles, for example. And when a driver returns to base, they just plug in the charging cord and either charging begins on the spot or later if they set a vehicle timer. If the fleet owner doesn't need the data and the billing functions, less expensive non-network charging stations can help to save money initially because the charging stations are less expensive and there's no ongoing monthly or annual service fees. So April's going to talk with us about ADA compliance. We'll switch gears a little bit there and talk about compliance with the Americans with Disabilities Act.
Great, thanks, Randy. In California, EV charging stations must adhere to Section 11B-812 of the California Building Code, or the CBC, which we call it. And this incorporates accessibility requirements from Section 11B-228 to ensure usability for individuals with disabilities. This includes providing accessible parking spaces as illustrated in the drawing here. This example lays out required spacing for ADA compliant parking and illustrates what the adequate width is for van accessible spaces. ADA compliance ensures safe and equitable access to charger infrastructure for all users. Keeping up to date with evolving ADA regulations is really crucial as changes may impact design requirements for future installations. Technicians and planners should regularly review these standards to maintain compliance and to avoid any potential issues in the future. When it comes to site signage guidelines, we feel that it's important to have clear and effective signage for EV charging stations. The photos here illustrate examples of visible signage, which is critical for making charger location, designating accessible parking spaces, and ensuring drivers can easily locate and use the facilities. These signs must be prominent, well lit, and compliant with local regulations, such as California's accessibility standards, and be visible to all users, including those with disabilities. In addition, signage should include any special instructions for operating the chargers, along with support contact details. Proper signage enhances the user experience, it promotes safety, and it ensures compliance with accessibility requirements. Let's discuss some of the most important EV charging installation best practices that will result in effective and compliant installations. Important steps in this process include site assessments, permitting and compliance, site preparation, and charging station hardware mounting. Safety for an installation is best achieved through the application of the National Electric Code Article 625 requirements. Randy, so let's take a closer look at each of these steps.
The National Electrical Code Article 625 is the cornerstone chapter in the code for safe and compliant EV charging station installations. It provides detailed guidelines on wiring methods, equipment specifications, and safety requirements for EV charging stations. This code ensures that charging station installations are designed and built to prevent electrical hazards such as shocks and overloads or poor connections, given the high power demands of EV charging. Compliance with Article 625 is mandatory for obtaining permits and passing local inspections. Adhering to these standards also guarantees reliable long-term performance of charging systems and minimizing maintenance issues. For design and installation professionals, knowledge of Article 625 is a key component of the EVITP certification process. Article 625 is the roadmap to follow for safe, effective, and compliant EV charger installations.
The installation of EV charging stations is really a multi-step process that starts with site assessment to evaluate the best locations for power availability and the necessary physical space for installing the equipment. So after locking down a site layout, you'll need to obtain the necessary permits to meet all of the national, state, and local codes. The preparation phase includes laying out the site, designing bollards to protect equipment, and pouring the necessary concrete foundations or placing them if they're precast. After that comes the electrical setup, trenching if necessary, running conduit, and pulling wire. Finally, you'll mount the chargers. You'll terminate the appropriate wires and then test the station and go through the commissioning process. NEC Article 625 governs every phase of the installation to ensure safety and compliance. During the planning portion, you'll want to consult with project stakeholders early. Clear communication with facility owners, inspectors, and utility representatives can help resolve issues with spacing or access or electrical design before permit applications are filed. And that can help prevent work having to be redone later, which also means higher budgets. Finally, it's really important to document everything through these various steps to simplify the permitting and the approval steps and to have good records just for future maintenance efforts.
So let's talk about some installation basics. For pre-apprentice and entry-level technicians, mastering the installation basics helps to build confidence and provides job readiness skills. Start by learning key electrical concepts for EV charging, voltage levels such as 120 volt and 240 volt charging, and the current ranges, which are from 16 to 80 amps for L1 and L2 charging, the higher voltages for DC fast charging, and grounding methods that help to ensure safety. You'll need to become proficient with tool usage, such as screwdrivers, wire strippers, torque wrenches, drill motors, multimeters, such as the Fluke 87V, and that will help to verify circuit parameters. You can practice mounting EV chargers on walls or pedestals and wiring them to panels using the appropriate manufacturer specifications. A 40 amp charger typically requires number 6 stranded wire and a 50 amp circuit breaker in the panel. And don't forget the importance of torque specifications for the wiring and terminating those connections, because if they're too loose, that can cause arcing or erratic current flow or voltage drop or heat, which are all bad things. Always verify your terminations using a torque wrench as recommended by the manufacturer specifications. There are dangerous voltages present when installing EV charging equipment. Good safety habits are a must for this type of work. The National Fire Protection Association 70E standard, which covers electrical safety in the workplace, defines arc flash boundaries by voltage levels and requires personal protective equipment, or PPE, to protect technicians from electrical hazards during high voltage work. Generally, the boundaries are higher as the voltage in question is higher. Lockout tagout practices, sometimes referred to as LOTO, were developed to ensure that equipment is de-energized and secured, and also to help prevent accidental re-energization. Special tags or locks are placed on or near the breakers or switches to get the attention of anyone that might want to turn the power back on while a technician is working downstream on the equipment. Adhering to these standards helps to minimize risks and ensures a safe working environment for all personnel. Site assessments are vital for ensuring that EV charger installations are feasible, safe, and compliant. We'll start by figuring out how many EV chargers are going to be installed and what their electrical requirements will be. Then we'll evaluate the site's power capacity, including the existing main electric service size and the available panel space if we're using an existing panel. Pay attention to NEC Article 625.54 requirements related to ground fault circuit interrupter protection. Many EV chargers have this protection built in, but if you're installing a receptacle for the charger, then this protection will need to be built into the circuit breaker that feeds the receptacles. Assess the ADA compliance and verify the necessary clearances and the equipment space that's needed, parking space dimensions, and that the proper ramp slopes for accessibility are there. Identify any environmental risks like drainage or flooding or coastal corrosion, and choose appropriate hardware for those conditions, such as a NEMA 4X enclosure if necessary. If using existing panels to feed the chargers, use appropriate metering equipment to check the voltage levels and document any findings such as voltage drop that will need to be addressed in the design and permitting package. And normally larger wire sizes are needed to mitigate that, or even utility involvement. And these steps will ensure a reliable, compliant installation. Permitting and regulatory compliance are critical for legal and safe EV charger installations. Start by securing electrical permits that align with local codes and NEC Article 625.42, which requires breakers to be sized 125% above the charger rating. So for example, a 40 amp charger needs a circuit that is protected by a 50 amp breaker. You'll also need to coordinate with authorities having jurisdiction, or AHJs, and their city inspectors to approve the plans and the permit application materials. Additionally, you'll want to make sure to include any required environmental permit information for trenching or other associated work, for landscaping or erosion control, and any required stormwater runoff compliance. Thorough documentation will ensure smooth permitting and inspections, as well as reliable installations. I'm going to hand it off to April here to talk about utility coordination.
Great, thank you, Randy. Utility coordination is critical for ensuring a reliable power supply for EV charging installations. And both Randy and I, having had backgrounds in the utility, we understand just how important this is. Engaging utilities early to assess infrastructure and confirm service capacity, especially if the job is going to require upgrading the existing electric panel, or if a new electric service and separate metering will be needed. We highly recommend the installation of some sort of dedicated meter for EV charging, not only so that the energy consumption can be tracked, but also to prepare the site to take advantage of EV rates offered by the utility. If building loads and charging loads are measured by the same meter, the site is usually not eligible for EV rates. And finally, we can't stress enough how important it is to document all aspects of the job, including all of the electrical details, such as transformer connections, switchgear information, and be sure to confirm any upgrades in writing with the utility to avoid delays and to support the permitting process. So let's talk about incentives. Utility incentives can help to significantly reduce the cost of EV charger installations for businesses and property owners. Southern California Edison's Rule 29, which is part of their Charge Ready program, covers utility side infrastructure costs such as distribution upgrades for eligible sites that are installing four or more charging ports. Equipment must be selected from SCE's approved product list, be networked, and operate on a time of use rate for 10 years, with enrollment in an SCE demand response program required to optimize grid load. So as you can see, there are additional requirements beyond a standard installation, but the incentives are usually worth it. The Los Angeles Department of Water and Power, which you may know by LADWP, in their service area, the Charge Up LA program offers rebates for commercial, medium, and heavy-duty vehicle chargers with up to $2 million per premises for qualifying installations. The resource page has links to both programs with the most up-to-date information. These incentives can make EV charging infrastructure more affordable and accessible. So check with your utility representative to see what applicable EV charging programs are available.
So when it comes to labeling and documentation, keeping good records on the job is really important, as well as clear and concise labeling of equipment. Per NEC 110.21, all panels and circuits must be labeled clearly to indicate their voltage and EV charger ID, ensuring safety and ease of maintenance for technicians and inspectors. Additionally, maintaining detailed records of equipment serial numbers, firmware versions, and IP and MAC addresses for networked chargers will help support troubleshooting, warranty claims, and any compliance issues down the road. Site preparation is critical for safe and reliable EV charging station installations. A good way to start site preparation is to design the initial layout with parking spaces, bollard locations, and charger locations, and ensuring compliance with all the applicable accessibility standards. Installing International Building Code compliant concrete pads for charging station bases, which are typically about 4 inches thick with rebar. In addition, use NEC 625.26 approved conduit materials such as PVC Schedule 40 or thin wall EMT conduit to wire up the charging stations. When it comes to underground utility safety, always contact 811 before trenching to locate any underground utilities. We recommend that you follow the 5 call before you dig steps, which are notify the service, wait for utility marking, confirm that all utilities are marked, respect the markers, and dig carefully using colored paint to denote conduit paths and the edges of slabs. These steps will help to prevent utility damage and ensure a high-quality installation. For power distribution, there are critical steps for safe and compliant EV charging wiring. You'll want to route and secure wiring using NEC-compliant conduit bends and pull in THHN type wire without overfilling the conduit and mounting hardware on sturdy supports such as Unistrut. Conductors must be sized per NEC 625.41, such as number 6 copper wire for a 40 amp charger, and use breakers that are rated at 125% of the load, with GFCI protection as required by NEC 625.22. Sometimes larger conductors are used when running longer distances to help mitigate voltage drop in the installation. Ensure that you have robust grounding by bonding to building steel or install separate electrode or a ground rod system. And if you're using aluminum wire, apply antioxidant to it, which is a paste, and the terminations as well to prevent dissimilar metal corrosion. These steps will help to ensure safe, reliable power distribution for the EV charging equipment well into the future. So now we're going to talk about load calculations. We need to ensure that the site's electrical system can support the number of desired EV chargers. So you begin by calculating the total new load and estimating the quantity, say, of level 2 chargers and include any DC fast charging that you're thinking about. If you're trying to power them from an existing panel, Apply NEC Article 220.83 on how to account for existing commercial loads and the new load to be added to calculate the overall loading. For a new electric service, once you figure out how many chargers will be installed, you'll work with your local utility to size the new service appropriately to handle the new charging load. For three-phase electrical systems, like you would find in most commercial settings, it's important to balance charger loads across all of the phases to help prevent voltage drop or neutral wire overloads. You'll need to document all of the load calculations and panel schedules thoroughly for permitting purposes. You can use one of the online tools that's available like Copperfield or spreadsheets to simulate various charger configurations. And the results from this exercise will then be used to fill out the permit application and be shared with the utility as applicable. For mounting options, of course, they vary by environment. Wall mounts are ideal for space-constrained areas. Pedestal mounts are better for open lots, and overhead mounts work well in multifamily or multi-story parking garages. Ensure that the mounting hardware, such as the anchor bolts, will be able to support the weight of the charging equipment, which is often over 100 pounds for level 2 units. The mounting solution also needs to provide 24 inches of front clearance for maintenance access. These days, in high traffic public areas, we also suggest using vandal resistant hardware and enclosures to enhance the durability and security of the installation. Selecting the right mounting option will ensure safety, accessibility, and longevity. Dynamic load sharing is a load management system concept, and it optimizes power distribution to prevent grid or equipment overloads and helps to reduce utility demand charges. So for example, LA County recently installed PowerFlex charging stations to comply with Southern California Edison's Charge Ready program requirements for demand response by controlling the power allocation across connected vehicles. One of the features of the PowerFlex system is that it can split the available power to charge cars based on the driver input on their app. So the screenshot here is from the PowerFlex app. Drivers provide input about their car's make and model and desired charging time and the number of miles that they require in their session. If one driver needs 30 miles in 1 hour and another driver needs 50 miles over 4 hours, the PowerFlex system prioritizes the faster charge, adjusting all of the charging rates to optimize the available power that they have to charge with. Load management in the form of utility demand response can help to reduce grid stress by lowering or shutting off EV charging during peak times in the evening and move vehicle charging to after midnight when the grid has more capacity. There can also be reduced utility rates to charge vehicles in the early morning hours when the grid has more capacity, and site hosts may be eligible to earn credits for participation in load management or demand response programs. In addition, submetering and energy logging are sometimes needed to comply with utility programs. Separate EV charging metering can be needed for compliance with these types of utility programs, and overall, load management and demand response programs help to ensure efficiency, promote cost savings, and provide grid stability during high demand periods. The overall process of getting the chargers ready for use is called commissioning, which validates the installation of the chargers and the infrastructure equipment and ensures that EV chargers are fully operational and compliant post-installation. The contractor will first go through a process called provisioning with the charging equipment, and then the network provider will activate the charger and connect it to their back-end system. Sometimes the contractor is involved in this step as well. Begin by verifying the voltages and making sure that they are within manufacturer tolerances. Test the communication connections and use an EV simulator like the Fluke FEV100 to confirm charging functionality. If different branded EVs are available, do some test charging sessions with them to ensure compatibility across vehicle platforms. Ensure that chargers respond to authentication methods such as RFID cards or app commands, and update firmware as necessary, and be sure to change those default passwords. Document all configurations and serial numbers and logs for warranty activation and compliance with permitting or utility requirements. Thorough commissioning guarantees reliable operation and security down the road. When done with the contractor items, work with a network provider if applicable to help them with the setup on their side. For networking best practices, there are key considerations for reliable EV charger connectivity. Make sure that the communication network is robust with good signal strength, whether you're using cellular or Wi-Fi or Ethernet. Weak signals can disrupt OCPP communication functionality and the associated billing systems or data transmission. When charging stations are installed in underground parking garages or in locations where the communication signals could be blocked or weak, it might be necessary to include repeaters or some kind of external antennas or some other signal enhancement strategy in the project to make sure that they can talk. Along those lines, if signal strength is an issue, avoid metal enclosures that may interfere with signal transmission and opt instead to use non-metallic enclosures or materials that allow better signal transmission. You might have to use external antennas or repeaters to help facilitate good charger to back-end communications. If applicable, research backup connectivity options as well, such as secondary cellular providers or wired Ethernet connections to help maintain uptime during network outages. These practices will help to ensure seamless data exchange and operational efficiency. When it comes to power quality, it's important to assess that during the advanced site assessment phase to ensure a reliable supply of energy for future EV charging. In order to assess the quality of the utility connection, you can use a power quality meter to verify that the voltage stays within plus or minus 5% of nominal and measure the total harmonic distortion, which is sometimes referred to as THD, per the IEEE standard 519. So in order to prevent equipment issues with dirty power, the recommended standard is to keep the total harmonic distortion level below 5% to prevent electrical interference from impacting the equipment. Poor power quality can also void warranties, so include voltage logs and screenshots in your commissioning reports for diagnostics and compliance. These steps will help to ensure stable long-term operation. April is going to tell us about future-proofing a job.
To ensure that your proposed EV charging infrastructure remains adaptable to growing demand and technological advancements, some level of future-proofing should be considered when designing and installing the infrastructure and equipment. You can plan for capacity upgrades by designing electrical systems to support additional chargers. For future charger expansion, include extra conduit or larger conduit, modular panels that can be expanded, conduit stub outs, and reserve space to simplify future installations. Stay informed about emerging technologies such as faster chargers or advanced load management systems so that new features can be integrated more seamlessly. These steps will help ensure that your infrastructure remains efficient, scalable, and relevant over time. The pre-inspection checklist process includes essential steps to ensure EV charging stations are ready for inspection and ultimately for compliant operation. First, visually inspect all wires for completeness to confirm that there are no loose or missing connections. Torque all electrical connections to NEC 110.14 specifications to prevent overheating or failures. Next, test circuits with a multimeter to verify proper voltage and continuity. Confirm the GFCI operation where necessary using the test button to ensure safety per NEC 625.22. For network chargers, verify connectivity and ensure OCPP functionality and remote monitoring capabilities are working properly. Document the commissioning process, including voltage and current readings, to support warranty activation and permitting compliance. Completing this checklist ensures a safe, reliable, and inspection-ready installation. When designing EV charging infrastructure, it's essential to distinguish between public and private use cases, as each presents unique considerations. For public charging, such as stations at retail centers, city lots, or curbside locations, you must prioritize visibility, accessibility, ADA compliance, uptime, and user-friendly payment systems to accommodate unknown drivers with varying needs and dwell times. In contrast, private charging, like workplace or multifamily housing installations, this serves a known user base with predictable usage patterns and longer dwell times, allowing for lower power charging and simplified access control. Private installations often integrate with building systems and emphasize cost efficiency, load management, and tenant or employee satisfaction. Tailoring design to user environments ensures infrastructure is cost-effective, reliable, and well utilized. This sample installation budget outlines the typical cost components for deploying 6 dual-port Level 2 chargers, providing a total of 12 charging ports. This would be at a commercial or public site in Los Angeles County. The budget includes key categories such as engineering and design, permitting, utility coordination, equipment procurement, installation, labor, networking, and site materials like bollards and signage. It also accounts for ADA compliance, including an accessible charging space, and includes contingency buffer to cover unforeseen costs. While actual project costs will vary depending on site conditions and utility requirements, this budget, ranging from approximately $166,000 to $263,000, offers a realistic framework to help stakeholders understand the full scope of investment required to support reliable, publicly accessible EV charging infrastructure. Keep in mind that this is only an example for educational purposes. Actual project costs will vary significantly based on some of the qualifications that we just mentioned. Regarding common mistakes, in discussion, the items related to a comprehensive guide on designing, installing, and maintaining EV charging infrastructure, we'd like to focus for a few minutes on avoiding pitfalls that can lead to costly delays, safety issues, or non-compliance. From site assessments to commissioning, we'll cover some of the mistakes that can occur, such as improper load calculations, neglecting NEC requirements, or overlooking future scalability, because these mistakes can undermine EV charging performance and regulatory adherence. We'd like to try to predict costly challenges when it comes to installing EV charging stations to avoid expensive setbacks. Mitigating panel space issues and trench costs involves accurate load calculations and utility coordination to optimize existing infrastructure and minimize excessive excavation. Preventing ADA access, rework, and retrofit issues requires thorough site assessment to ensure compliance with accessibility standards, like the required clearances, and to plan for modifications in existing structures. Using hardened enclosures and site protection strategies can help to safeguard equipment from environmental damage or vandalism, especially in high traffic areas. Proactively tackling these challenges can help to reduce costs and will ensure durable, compliant installation. So Randy, let's dive into some of these common mistakes.
Well, we've seen quite a few issues over the years when it comes to EV charging installations, and avoiding some of these common mistakes can really help the site to be safer and more compliant with regulations, and ultimately a better site overall. The first thing that comes to mind is the practice of undersizing neutral conductors on multi-wire branch circuits, and how that can lead to overheating and circuit failure when it comes to EV charger sites. So you have to ensure that all conductor sizing calculations are done per NEC guidelines. Missing Equipment grounding conductors can compromise safety and violates NEC 625.54 requirements for proper grounding. Using unlisted connectors instead of approved ones risks poor electrical connections and potential hazards, so always use listed components. Failing to properly support conduit as required by the NEC can cause structural issues, while missing weatherproof covers on outdoor outlets leaves equipment vulnerable to environmental damage. Inadequate working space per NEC 110.26 hinders maintenance and inspection, posing security risks. Avoiding these mistakes will help to ensure reliable, code-compliant installations.
Well, and this next part, Randy, is kind of one of my favorite, where you're just going to go through what actually goes wrong at these sites. So I'm excited to hear you walk through this and to show us exactly some real world examples.
We have the photos, we have the receipts, as they say, right? And sometimes photos are hard to get because people don't want to advertise, poor work quality, but we have the photos. So in this section, we'll be reviewing some photos of what we call EV charging installations gone wrong. We have some actual photos from the field, and we'll point out the issues and what might be done to prevent the issues in the future. So this first photo shows a ground wire that's poorly fastened to the wiring block. You can see there's strands of copper that are dangerously close to the black hot conductor on the left. This is a sloppy connection, and it risks a short circuit, which could lead to equipment failure or even some kind of an electrical fire. Always secure wires tightly to the correct terminal, ensuring that there's no loose strands. Use the proper tools and follow the manufacturer specifications for tightening. So in this photo, we see a ground wire that forms a large loop, the green wire there near the cabinet door, and it got crushed by the mounting screw for the cabinet door. So this has really damaged the ground wire insulation, and it's created a grounding failure and a potential shock hazard. So you want to route wires carefully to avoid these type of pinch points and secure them away from moving parts like the cabinet doors. This next photo, it doesn't look like much. It shows a piece of rigid conduit between two electrical cabinets, and the upper conduit is installed without the lock nuts that you see on the lower ones. Well, without lock nuts, the conduit can loosen or move and ultimately can expose wires to moisture or physical damage. So you always want to use lock nuts to secure conduits, ensuring a stable connection that meets the NEC standards. So this photo shows a Fluke multimeter doing a continuity check on one of the EV charging cable conductors, and it's showing 44,000 ohms or 44 kilo ohms, which is a very high reading for a continuity check. So this is a major red flag. Resistance should be near 0 ohms for efficient power delivery. High resistance indicates either a damaged or a poorly connected conductor, which can lead to overheating or charging failures. So you want to test all conductors with the multimeter like this before commissioning, but ensure proper connections and replace any cables that are damaged or tighten connections if necessary. So this photo shows a flexible conduit between two cabinets. They're leaning against the wall without any bracing or wall bracket supports. And so unsupported conduits can bend or even pull loose, stressing the connections inside and exposing wires to damage and moisture. So you need to secure flexible conduits with appropriate brackets or straps and follow NEC guidelines for the support intervals on how often they have to be supported with those brackets. This is an interesting photo because it shows the black and the ground wires. They're twisted really improperly at the terminal block connecting point, so there's visible loose strands. Poorly twisted or unsecured wires can loosen over time, risking contact with other terminals, which can cause short circuits or arcing or equipment failure. So you want to ensure that wires are properly stripped to the right length, twisted slightly, and fully inserted into the terminal block. And you have to double check to make sure that there's no exposed strands. I love this photo. So this photo shows a conduit in a parking structure, and it's floating in midair. There's 45-degree bends. So instead of hugging the walls with support brackets, it's actually up in the air. This setup is not only visually unappealing, but it risks physical damage from either vehicles or stress on the connections. It violates NEC standards for secure conduit installations, and it certainly wouldn't pass inspection. So you want to route conduits tightly along the walls or ceilings using the proper fittings and supports to ensure stability and compliance with all the electrical codes. Boy, I had to cringe when I saw this photo. So this is an electrical panel with screw terminals, and they're severely stripped, probably from the person using an improper tool to tighten the connections. So stripped screws like this, they really compromise the connection's integrity, leading to loose connections over time, overheating or arcing, which can cause fires or equipment failure. And in addition, their condition makes it nearly impossible to do any work on the panel in the future. Very difficult to get those screws out. Just not an attractive installation. So you always want to use the correct screwdriver or tool to tighten those terminals and replace any damaged screws or terminals if this happens, because you want to ensure that you have secure connections.
That was great, Randy, because it really does show what happens in real life at these EV charger installations and how just what seems like it may not be a big deal when you're doing the installation over time turns into a major problem. So thanks for going through those. We've put together a case study that highlights a retail site successful EV charger installation demonstrating how early utility coordination and strategic planning overcame a tight schedule and stringent uptime requirements with standard EV charging equipment. So Randy, why don't you walk us through that?
Very good. Yeah, so this case study looks at an EV charger installation at a retail site, and it showcases really an effective planning and execution process. So they had early engagement with the utility. They ensured their adequate power capacity for 4 level 2 charging stations, and each one is fed by a 50 amp breaker that we've talked about before, and that number 6 wire, and requiring a new utility electric service and meter for this installation. So the challenge for the project was a tight installation schedule, and they, of course, have to have a 99% uptime requirement post commissioning. You'll see this in a lot of retail sites. They actually have blackout periods depending on holidays and shopping, Thanksgiving, and so forth. They don't want construction to occur during some of those times. So this was a very tight installation schedule. The solution here involved installing pedestal mounted chargers, networking them via a cellular OCPP connection for the reliable backend communications to the backend there to the network provider, and monitoring those connections. Tight coordination with the utility and the AHJ inspectors, and very high quality submittals that went in at first to be approved, without having to redo them. Streamlined the permitting and inspection schedule for sure, and ultimately allowed the project team to meet the aggressive timeline while ensuring compliance with all the rules. So this approach delivered a very reliable charging solution. The uptime has been high. It's been a success all the way around.
That's great to hear that that was a success. And moving into contractor and electrician certifications, they are required for many publicly funded EV charging station projects, including the EVITP certification, licensing, and training. Let's dive into this a little bit deeper. We've put together a pathway to certification that outlines the steps to achieve electric vehicle infrastructure training program certification, equipping installers and technicians for the rising demand in EV charging infrastructure. The first step would be to obtain a journeyman electrician license or complete 8,000 hours of electrical experience, followed by coursework in electrical fundamentals and NEC compliance. Next, you would need to complete the 20-hour EVITP course itself, which covers safety, site layout, equipment, and codes like NEC Article 625, and then pass the exam to validate your expertise so that you can build on publicly funded projects. In addition, there is an OSHA 10-hour course that includes first aid, CPR training, and this course is recommended and is often required by project managers to ensure job site safety. These certifications enhance your credibility and project readiness for EV charging projects. So the key takeaways from this presentation are comprised of critical considerations for successful EV charging station installations, and they include a thorough site assessment that prevents costly rework by ensuring power capacity, ADA compliance, and environmental suitability, setting the foundation for reliable chargers. Proper permitting aligns with local codes and NEC Article 625, avoiding delays and violations. Effective site preparation includes concrete pads and conduit runs, and this enhances safety and durability. Correct mounting options like wall or pedestal mounts ensure accessible and long-term serviceability. Throughout all steps, adherence to NEC Article 625 is essential for safety and compliant installations. These principles ensure efficient, durable, and code-compliant EV charging systems. We've assembled 2 pages of links on relevant topics from this presentation that you might want to dig a little deeper. So for example, we have some links that will provide additional information about electrical codes, utility incentives, and EV charging codes. In addition to that, we've provided a resource page where we have links for additional information on the LA County 5-part site selection best practice series, installation training links, charger locator maps, as well as technical assistance. Randy and I would like to thank you for watching the webinar. We hope that you were able to get some good information from all of the materials. And if you have further questions, don't hesitate to reach out directly to the County of LA, to Laura Inaconi and Jennifer Caron at the email address listed here. They would love to hear from you. And thanks again for your interest and your time. And we'll see you at the next one.